Next speaker is Mr. Stephan Wuthrich. He's from Switzerland. He's a civil engineer with postgraduate studies in economics and environment. He's also a member of the management board of CSD Group and a member of the Task Force Sustainable Development. Please welcome him. Δεν υπάρχει διάλειμμα. Συγγνώμη, δεν υπάρχει διάλειμμα αυτή τη στιγμή. Μόλις τελειώσει η επόμενη παρουσίαση, υπάρχει διάλειμμα μισής ώρας.
I have to put it myself? Have you got everyone? No problem. Is this working?
Παρακαλώ λίγη ησυχία για να αρχίσει ο κύριος Wuthrich. You can start now.
Okay, good afternoon. Thanks that I'm here. It's glad to present you our experience in construction waste management. You may ask yourself, what has it to do with energy? Construction waste management. I was asked by Mr. Papadanias to present our experience we've got in Switzerland about this subject. I just would like to have a few words to present the CSD Group, then to give you a short introduction in the subject, but mainly to show you how we do with construction waste in Switzerland, to show you a few principles, a few examples of the actual practice in Switzerland. CSD is an engineering company active in different fields. We are developing and we ensure that our client, they get economical engineered solutions with quality of life and environment. So we try to get solutions with in a sustainable way. We are doing project planning, infrastructure, green building and renovation, energy efficiency, a big subject. Then the resources and waste management subject we are talking about today. We are working in different branches all over Switzerland and Europe, and we try to get together our specialists for the right solutions for our clients. A short introduction about the waste streams in Europe. You can see waste stream in the 27 EU member states. It's a huge amount of 2.6 billion tons of waste, and about this 2.6 you see that it is 32% of construction and demolition waste actual today. The built environment is a huge part of raw material. It's enormous. If you take the values here, it's only for Switzerland, which is quite small. We got 2,400 billion of Swiss francs. If you want to replace this Swiss building stock, we have to maintain it with a huge amount of money every year. And we count in the next 20 years around 65 billion of Swiss francs only to maintain this park of buildings. And you see more than half of the country's energy today is used for construction, operation and deconstruction of this park of buildings. Construction waste management, you see in the middle, it's the actual stock of the whole area, whole country, and you get the inputs like mostly gravel and sand, which gets in the system every year. We got here not this much, but it's cement. Here up, it's bitumen, and you get this 2.1 stock today. And you see that there are some materials going out of the circle, and we try to get back as much possible in this stock. So we try to get a certain balance. I've a piece of concrete here, which is made of recycled material, which we see afterwards. Maybe I give it around. You can get an idea what it looks like, how it feels. So this was the actual situation. This here, you see in the upper part here, today we get a lot of material into the system. The building stock is about 2.1 billion tons, and you see it's still increasing. Every year it's increasing about 60 million tons. Then you see our vision. We have got the vision that we should try to get a kind of balance. So we get the material we need for the stock, for the buildings. We get it directly from the warehouse, if you want to. So we try to balance this kind of material flows. But this is a vision. You see, it's 2050, so we hope to manage it one day, but it's a long way to go. Some principal legislations in Switzerland we try to avoid first. If we can't manage to avoid, we try to reduce, to reuse, and then to remove at the end of the life cycle. I think it's logic. Then since 2000 there is a ban of depositing combustible waste. We have recycling requirements where we have to recycle. We are not free in this choice. We try to close the cycles of materials. We try to avoid the environmental impact. And of course, the economic viability is very important as well. What types of construction waste do we classify? We talk about excavation from the big infrastructure projects, from excavation from the soil. Then we have got the mineral construction waste, where you have the real material you can reuse. We have got the combustible construction waste, which goes to the incineration plant, which we can't reuse again. And we have others. We'll see it later. If we take the mineral construction waste, we talk about asphalt, about road rubble, about concrete rubble, and about mixed rubble. And we try to separate these components as soon as possible, to declare it, if possible or if necessary, to treat it, to ensure the quality, and then to get the actually primary material again. So actually down here you get asphalt granulate, you get recycling gravel sand, we have got concrete granulate, which is the biggest part at the moment, and you got the mixed rubble granulate for the mixed from the mixed materials. Here in pictures you see at the left the asphalt rubble, where it's from the infrastructure constructions, road rubble, concrete, and the mixed rubble when it's not possible, mainly bricks, when it's not possible to get it back in a proper way. And then the materials, you get out this asphalt granulate, which gets back in the circle. You have the gravel sand fraction, the concrete granulate, and this mixed rubble granulate looks like this, and it's what you can see in this example, which is circulating. It's the red spots in there is actually old bricks, and it's from this mixed rubble granulate. Bulky construction waste is all what's unsorted. Sometimes when you have not a lot of space, it's not possible to sort it in a proper way, so you have to sort it afterwards in a installation plant where you try to get out most of the values, so you get away everything which is combustible, which goes after in the incineration plant, and we try even to get it by manual sorting system to get out most of the values in this waste. Some practice in Switzerland, maybe some examples who can show you how we do, why we do it this way. First, we try to act all along the life cycle. So I think if you talk about waste, you talk about end-of-pipe system, end-of-pipe solutions, and we try to act already before, so that already in the production of the material, in the choice of the materials, in the planning of the buildings, we try to act already before if possible, not only at the end, and to say now we have to try to find a good solution at the end of the process. So it's the idea behind the life cycle approach. One important experience is to separate the systems. Like if you have a primary system like this, it's a bit, imagine the primary structure which we built for 50 to 100 years. Then we have got secondary systems like the ventilation system or everything which is sanitary systems, where maybe 15 to 50 years, it depends. And you have the tertiary system, about 5 to 15 years in this case here. So we try already in the planning phase, like it was made here actually, you see that you have different systems. They were separated so that it's possible to separate it after 20 years without damaging the primary system structure, for instance, or there are other details in the facade mainly where you can apply this kind of principle. Then we need a lot of planning aids. It's more or less best practices we got over the years, and we try to, especially the architects and the engineers, they got norms, standards, directives, and they put it down, and we get some practical help all over the process to help constructors and planners to get a good solution. So it's an important thing too. I'm sorry that it's not all in English. I just got it like this, the way it is today in Switzerland. So I hope you can understand it. Close the material cycles. I think it's more or less clear. It's to get really up here to deconstruct, not to demolish, and to reuse and to get it back in the primary material way. Deconstruction, even in Switzerland, a lot of people they talk about demolition today, but I think it's a right way to talk about deconstruction, so that we really do it in a systematical way, in an order that it's going to work, that you prepare, you decontaminate in a way that you get off all of material which is problematic, you get off all the material which disturbs you later, remove the interior, and you dismantle actually the building in a way, the same way that you were constructing it maybe 50 years before. Another important thing is that if you want to get a permit for building or rebuilding or renovating, you need a permit. You need like a deconstruction concept. You have to show how you handle all these materials. So you have to show to the authority how do you want to plan this, and afterwards you get the permit. Otherwise you have no permit. So I think it's an important way to do, otherwise nothing happens, and as soon as you get the permit you have like the green card and you go on. So it's an important way and principle today. Then we have got this, we call it, I don't know if the translation is right, we call this the multiple dumpster concept. So you have this kinds of, we try to get as most possible back in a proper way. Like in the dumpster one, you get only single material, like concrete, like wood, like everything which is really clean, and you can go back directly in the circle. We have got the dumpster 2 with mixed rubble, which is already more difficult to find a way to bring it back in the circle. And we got all what's combustible, it's clear, which we can't reuse. It goes directly to the waste incineration plant. And the dumpster 4, it's all material which we can see very often. It goes in this treatment plant where it gets sorted, where we try to get back the values and the interesting material. What's very important, I mean, it's important to see or to know how can you reuse this material. I think there's no sense to try to get it back when you have no reuse. So for this we got some regulations. They show you how you can reuse this material, what kind of material at what place, in according to the environmental legislation. This is one side. And on the other hand, you need quality requirements. You have to define what's a concrete, recycled concrete material, what's the mixed rubble, to get a good material back, not to damage in long terms the materials and the buildings, and that the image of the material as well gets maintained. Here an application example of concrete recycling, how it's actually practiced in Switzerland. A lot of public authorities, public investors, they use this kind of, directives. So it means that concrete granulate, it's not really a problem. You see, you can use it even in the walls outside. You can use it, everything which is in the cellar system, no problem. And you see that the mixed granulate, so bricks, a bit problematical material, there you see it's no problem to get it inside the building. And today, actually, a lot of buildings are made this way. So we try to get it back really in the building system. And there is a lot of innovation every year, and it changes a lot, and it's a kind of change of behavior. And even the constructors, they help us, they try to get further and to find new solutions to get this material back in a proper way, with treatments, pre-treatments, and to get a good way to put it back. What about the physical parameters of concrete recycling? It's not this easy. We can't say that it's the same quality. The engineers, they say, for me it's a problem because I have to ensure the quality of my building. And then you can see the 100% concrete granulate, it's around here. This diagram shows you the elastic modulus at this side, and here you got the compressive strength. So everything which is on pressure, it's not really a problem. You see that even with the material with mixed granulate, you get around 35, 40. So it's more or less the same. But if you see then the A modular, you need for instance, for ceilings where you have long, wide-span buildings, there it's more important to really to take care about the choice of this material, and there you are better with the concrete granulate. So it's more sure to get a good product. What are the trends? In general, the trends, maybe even the facts. Actually, in Switzerland, we talk about recycling, not about disposal. Disposal at the end only if it's really necessary. We talk about waste management. and today more about resources management. So waste, actually, all the waste has a kind of value. Even if it's incineration waste, you can get some energy back. And especially it's important to say all the waste is a kind of resource. So it's an important aspect. We don't want to talk about demolition, we want to talk about deconstruction. Cradle to cradle, very popular at the moment. A lot of people talking about cradle to cradle. Urban mining is getting popular, like we said before, this big warehouse, this big building park. Then the landfill mining is starting in the sense that especially in landfills where you got a lot of metals, like from the incineration plants, there a lot of innovation is going on. We try to get this back, even from the landfills, to get out the values, the rare metals. And we want to improve the ecological footprint by product design. I think this is a trend which is going on already since a long time. Then an approach, maybe you missed it you saw it already by Mr. Olivier Francais. It's the 2000 watt approach, we call this. So we try. Actually, in Switzerland, we are around 5,000 watt. It's not the actual number here, but actually each citizen uses today 5,000 watt permanent energy. And we know if we want to get sustainable, to live in a sustainable way, we have to get down to 2,000 watt. So what does it mean for construction and the building companies and the building sector? Actually, for living, we get like a budget of 900 watt, I would say, 1,000 watt. And then you see that you have to handle your budget with these values. So what happens today, a lot of cities like Lausanne, like Bern, they say we want to realize our development with 2,000 watt approach. So we want to be conform with the sustainable development. And for this, the planning or the architect, he gets a budget for his 3, 4, 5 buildings. And then he has to work with this budget, with the construction material, with the mobility, everything which is around the warm water, heating, electricity. So it's his liberty how he does this, but at the end he has not more than 1,000 watt. So this is the actual way we try to go without taking the liberty for the planning and architects. And I think it's a good way to do, and we have got the very good experience in the last 2 or 3 years. Another trend, I think it's about the labels, the standards. It helps us to ensure the quality. A lot of all these standards, they have got criteria like resources, you have to be efficient with the energy, you have to bring back, to close the recycle, to close the materials flows. Especially like Minergie, which was presented this morning. There you have to show that you reuse recycled materials like concrete materials. So it's a compulsory to use recycled material to get this label. So it's a way to motivate the investors, to motivate the planners to do it in this way. And finally, even cross-certification. This is an actual project in Bern, where we get the Minergie P-Eco label. Minergie is for energy efficiency, and the Eco is for well-being, for everything which is material, resources, efficiency. And at the same time, we try to get the 2,000 watt society approach done in the same way, so that we can really talk about sustainable construction, building, not only energy, not only resources, but only in a larger way of the sustainable development. Thank you very much for your attention.
Dankeschön, Herr Wuthrich. Very interessant. Is there any questions for Mr. Wuthrich?
Excuse me, the term is 2000 watt or 2000 watt hours per year? Because it's energy. And you are the second speaker that says the same. The target is 2000 watt hour.
The target is 2000 watt permanent energy for one citizen.
Watt is not a measure of energy.
Yeah, it's
watt hour, but the term is 2000 watt.
Yeah.
Let's say you use it.
Yeah, you use it as
instead of 2000 watt hour.
No, it's not 2000 watt hour. It's really the permanent energy we calculated in this way that it's a permanent energy we use per person there.
Watt is not a measure of energy.
Yeah,
that's the problem.
And, okay, you can say in
yes,
an hour.
What is it?
In an hour, it's then 2000 watt hour.
Is watt hour.
Yeah.
But the term, let's say we say it like this.
Right.
Okay.
If we talk about permanent energy, so it means that permanent, you get today 5,000 bulbs burning. But of course, per hour, it's per hour.
And this is 2000 watt hour per year. This per person.
Per hour, it's per hour it's 2000 watt per person.
Okay.
Is there any other question?
Thank you. I wanted to ask you, are the recycled materials more expensive to use compared to, let's say, concrete? Buy new concrete and use it. I mean, what's the benefit? Why use the recycled material?
It's a very good question actually. If you take the example of the concrete, it's more difficult to get it back. It's more. It costs you more actually. All the people working with gravel today, they take the gravel from the nature, and they get it an easy way back in the circle. And with the concrete, the recycled concrete, it's more expensive, but actually on the market it's the same. The market in Switzerland, it is more or less the same price. Some regions, it depends if you have got gravel, natural resources. There it may even be cheaper. And if you haven't got material, so it depends a lot of the regional situation. But it's more or less the same.
Is there any other question?
Yeah, I have a question. Sorry.
No problem.
Based on, I wonder if you have previous experience with projects. In what sense? Say we approach a customer that is purchasing an existing building, and their whole purpose is to tear it down and build a new one. Now, in your experience, what if there's any benefits if I want to persuade my customer instead of just paying for demolition like the old way and building a new building, or running it through this program? In your experience, what is the benefit on a financial basis to actually do this, recycle and reuse for the new building? Is there like a cost reduction in the whole project of demolitioning and construction?
I think it depends very of the project. We have got one example where we took all away, only the main structure was still okay, because it was about earthquake reasons. It was like an economical calculation was done, and finally we could show that it was more interesting to let the primary structure for economical reasons and ecological reasons, and instead of tearing it down. But there are some examples where we take away everything because the existing structure is not made in a good way. Earthquake, you are not flexible in the architecture. So it depends of different criteria where you have to go through to decide if it's better to take it away. There's no recipe to say in general, but I think in the future we try to get more space and more flexible systems. There will be more deconstruction and really rebuilding new buildings.
There is no other question? Okay. Thank you very much also for attending the previous presentation, although it was in Greek.
Thank you very much. Thank you.
Θα ήθελα να σας παρακαλέσω, αν μπορείτε, να περάσετε από το παράρτημα της ΑΣΡΕ, είναι όπως ανεβαίνετε πάνω ακριβώς στα αριστερά σας, και να στηρίξετε και εσείς την προσπάθειά μας, έτσι ώστε να μπορούμε και εμείς να έχουμε τη δυνατότητα στο μέλλον να διοργανώνουμε τέτοια συνέδρια για σας.